Hi everyone, I am Ramakrishna Kalluri, TA of Ganpati Krishnamurthy sir. In all artificial intelligence related problems, be it either ML problem or a DL problem, like machine learning problem or deep learning problems, to solve any kind of problem, fundamental thing that is necessary is data. Okay. Once we have data, using this particular data, we are going to train a particular model. Using this particular data, we are going to train a model. Once the model is trained, we will use some new data to feed as input to the trained model. So it will predict some output. The main goal is we should train this particular model in such a way that whenever new data comes, it should predict in a desired way. This is the whole idea of this entire training a model. Okay. What sort of data that is available in a digital domain? Okay. First thing is images you can expect. Second thing is videos you can expect. Third thing is like CSV or Excel files. Mostly the numerical values or tabular data will be stored in CSV or Excel files. Videos. Similarly, we can have text data. Okay. Let us assume that these are the four sorts of data. One more thing is more or less like speech kind of a data. Speech data. Or we can say one-dimensional data. Okay. These are the several ways in which data are available in digital domain. So whenever you want to feed the machine learning model or deep learning model data should be sent in a particular format to both machine learning and deep learning problems or deep learning models. Okay, irrespective of the data, like images, videos, speech data, one-dimensional text data, or CSV, Excel files, all these data should be converted into NumPy array. This is the fundamental thing one should be noted while dealing with machine learning or deep learning problems. Summary is, irrespective of the data, we should convert that kind of a data into NumPy array format. Suppose if you take as ML problem, machine learning problem, NumPy array can be directly fed into the machine learning models. Whereas into the deep learning models, we should convert this NumPy arrays into tensors. Okay, before feeding the data into deep learning models. Okay, this is the usual way. So one should be familiar with NumPy array library in Python. Okay. Now coming to second thing, in order that to load files like CSV files or Excel files, we need pandas library, where in this pandas library we are going to feed the CSV files as data frames. Once you convert the CSV files or Excel files into data frames, further it will be easy for us to handle the data to do our data analysis. Okay. So to work, just I am explaining whatever are libraries that are very much important to start off working with either machine learning problems or deep learning problems. Fundamental thing that is necessary is NumPy array. Second thing is pandas library. Third thing is matplotlib. Okay. While dealing with the data, you always try to visualize the data. Like suppose if I have an Excel sheet data, I just want to see a column of data as a graph. I can use that particular column of data and I can use this matplot library for the visualization of the particular column. How exactly data has been distributed. Okay. To get some visual picture, we go for matplotlib library. One more library that is also mostly people use, that is like Seaborn, Seaborn. So one should be familiar with both Matplotlib and Seaborn is a added advantage. So if you know Matplotlib alone, that is also fine. Next thing is machine learning models. To get familiarized with the machine learning models or how to use this particular machine learning models, one should be familiar with scikit-learn library. Okay, one should be familiar with scikit-learn library. Irrespective of the data, whatever you have data, you should convert that particular data into NumPy array. After converting into NumPy array, we should use that data directly into the scikit-learn library. Okay. Now coming back to deep learning models. Okay. In order that to train the models of deep learning models, we just have to be familiarized with the either PyTorch library provided by Facebook or TensorFlow library. So make sure that get familiarized with either PyTorch library or TensorFlow library. Okay. Before feeding data into this particular PyTorch or TensorFlow libraries or PyTorch or TensorFlow models, first we convert the data into NumPy arrays. After converting into NumPy array, we should convert that into basic tensor format. Okay, these deep learning models expect data in terms of tensor format. Okay, this is the whole idea. The summary is, to start off your work in machine learning problems or with the deep learning problems, you should be familiar with these kind of libraries. First and foremost is for NumPy library. Second thing is Pandas library. Third thing is Matplotlib library. Fourth thing is machine learning models related, that is scikit-learn library. Next thing is deep learning models related models, that is PyTorch library or TensorFlow library. TensorFlow library is provided by Google. PyTorch is library provided by Facebook. That's it. So to get your hands on using Python to solve any kind of AI related problems, you should be aware of this stuff. Okay. Once we obtained the data, the usual procedure to solve any ML problem is to please split this data into trained data. Second thing is validation data. Third thing is test data. Okay. Suppose if you have some 1000 data points, okay, you can divide either it like 70% is for train, 20% is for validation, and third one is test data. Okay, but why? That is the question. Suppose I have used this, instead of using this validation data in between, what I can do is directly I can use 70% is for training and the whole 30% is for testing. Okay. Mostly ML problems suffer from overfitting problems. That is the metric. Let us assume that the metric is loss value or error value. That particular loss value is less for trained data. Okay, after training, we are going to get very less error or loss value for the trained data. Whereas if you test the data, if you use the test data on the trained model, you will get loss value as high. Loss value is high for the test data. This is nothing but overfitting problem. Okay, so our goal is to always try to maintain the balance of both train data and test data, loss values of both train data and test data should be more or less same. That is how we should design the models or train the models. So what happens, suppose this on this particular test data model is not giving less value, just like for the training, just as training error. That means again you have to train the model. Okay. So suppose second time also I have done and I have used the test data, same thing happened. Again third time again I have trained, now I used my test data, again happened that we are not reaching the error value or loss value more or less same to train data. Okay. So while training the model itself, instead of after training and doing instead of doing the validation after the entire completion of training, we came up with validation part. We came up with validation part while the model is training. Okay. So yes, the instead of from those 30%, we are converting into 20% into 10%. Okay. This 20 indicates validation. This one indicates test. Okay. So while the model is training, validation loss is not improving, or I mean validation loss is not decreasing. Again the model will train in such a way that validation loss also should be low. Okay. So the advantage is here, while training the model itself, we are just testing whether that particular model is performing well or not. Okay. So once this entire training is done, only once we can use the test data whether this model is performing well or not. Okay. That is the basic idea behind using validation dataset. Okay. The summary is, validation data will help you to train the model in a better way while doing the training itself. Okay. So the usual procedure is, either you can split the entire data into a 70%, 20% or 10%, or 80, 10% or 10%. This is how you should use this one. Okay. Next thing is cross validation. One should be familiar with. Cross validation is nothing but, since I am using validation, assume that I am training my model like this. Suppose this is my train data, entire train data. One iteration is done. In the second iteration, I will use this part for validation and remaining part for training. Here I am using this part for, suppose this entire data is like whole data which we are going to train. Okay. While training, I am assuming that in the first iteration, all these points I am taking as train and these points for validation. Okay. Let us assume that I am doing this cross validation like 5 times. Okay. In the second iteration, what I do, instead of taking these same points as validation, I am taking some other points and remaining as, again, they act as training points only. Similarly, in the third iteration, we can choose these points as validation part, remaining as training points. Likewise, I will do for all the 5 iterations. This is nothing but cross validation concept. Okay. To do all these tasks, to automate all these tasks, whatever we have, something like cross validation and all the implementing of this model, everything we should be familiar with the libraries. That's it. There is nothing else. Now coming to ML problem settings. most of the times you can see that either classification problems or regression problems mostly. Suppose if you observe this breast cancer dataset which Sir has discussed in the video also, here this is how the dataset will be given. Like we have some x1, x2, x3, like xn features we will have, and this one we call targets. These are called features. These are nothing but targets. This is how the data has been provided. Suppose in terms of classification, the output values like target variables are given as depending on the number of classes. Suppose I have some n number of classes, so I will give the digits from 10 to n minus 1. That is the usual criteria. Even you can give some distinct numbers also, that is up to you. But mostly this is how the people will give in problem setting with respect to classification. Now coming to the regression problems, we will be given same like that CSV file where we have x features. These are nothing but the features and these are nothing but the targets. Okay, regression means continuous. Here if you observe the outputs, here you can see they are all continuous values like 2.4, 3.5 or some any other kind of any real number. Okay, so in summary, most of the times while dealing with the regression problems, we will be given data in terms of either CSV files or Excel sheets, where you will be given the, suppose we have n number of data points. For all the n number of data points, we have some n features, and correspondingly we will have target variable also. Okay, this is how the data has been given. Just here I have discussed like this, where features and targets are given. Our task is to using this particular data, like suppose you have some m data points you have, I have to prepare a particular model or train a model by using this kind of data set. That is my task. Here, especially the linear regression problems, where we will be given data like this and we have to generate a function like this, like y hat is equal to beta naught plus beta 1x, where suppose assume that for all the data points we have only two dimensional, only the data is having only one dimension. Like suppose I have only x has only one column, y target anyway it has only one column. Suppose you have only one feature, or in terms of you can say unique variable you have. At that point of time we will go for univariate linear regression, where you will try to generate this function y hat equal to beta naught plus beta 1x. Using this particular loss function, we are going to estimate the beta naught and beta 1. This will be taken care by the library, what I have mentioned as a scikit-learn library. It will take care of to estimating this stuff. After fitting the model, we in theoretical part we say that we will estimate beta naught and beta 1. Once we know the beta naught and beta 1 values, for any new kind of data point comes, suppose x value, new value comes like x new. Now I will substitute here y output equals to, I will give beta naught I already know from the model, beta 1 I know already from the model, and I will substitute this new value and I will predict this particular y out. This is how the criteria goes. Okay, in summary, suppose you have only one variable in terms of independent variables, or in terms of features we can say, where y is nothing but the target. At that time we call it as univariate linear regression. There we are assuming just this particular function beta naught plus beta hat next, it will take care of. So okay, we are saying that the training is going on. Okay, but while the training is going on, we should be in a position to evaluate while the training itself is going on. Like we need some metric. Okay, while the training is going on, we have to see some metric. So okay, if you are able to find that metric is good enough, that means the training is going well. Like that, in linear regression problems, we have three metrics. Most of the times people will use these three metrics only. Like R square value, it is given by here, this kind of a formula, where yi is nothing but the original targets are the data that is given. Okay, like down to data. When it comes to yi hat, this is nothing but the predicted value. Okay, this is nothing but the original target value, this is nothing but the predicted value. Next, yi bar is nothing but mean of all the target values, Okay, this is one sort of a metric. we expect this value to be 0 to 1 in general, and I need a value of 1. Suppose after fitting the model, if you are getting one value, that means we have developed a very good model. Okay, that is very good. Next thing is mean square value. This is the metric. Similarly, you can also say that it has mean absolute error. These are the three metrics we can see in designing a linear regression problem. Till now I have discussed only metrics related to linear regression. At the same time, I have discussed only with respect to univariate linear regression only. That means independent variables are features, we have only one, targets we have. Okay. Now coming to multivariate regression. It is just another extension of this univariate regression. Instead of only one beta naught and beta 1, we are extending these coefficients now. Suppose in case I have x1, x2, x3, x4, likewise I have xn, like n features I have. For every data point I have n features, n data points, n features. We just have to build this particular line. Usually, since it is not a two-dimensional plane, that is why we call this one as a hyperplane. Okay, not a line, hyperplane we call. Okay, here we, instead of estimating just beta naught and beta 1, we are extending our task and we are estimating remaining things also. Okay, I have already told you that is the basic difference between multivariate linear regression and univariate regression. That is, univariate regression you will have only one variable as a features, whereas in multivariate regression you will have several variables, okay, or several features. Now coming to Python implementation, here I am going to use the scikit-learn library only. So most of the times, whatever the task you do with respect to machine learning, you must be focusing about NumPy, Pandas, Matplotlib and scikit-learn. I request everyone to please be familiar with these 4 libraries. Suppose if you are dealing with deep learning, you should be familiar with also TensorFlow and PyTorch. Okay. People who are in academic domain or research domain, most of the people, I request you guys to please go with the TensorFlow. Okay. Whenever a new research paper comes, people are releasing their code mostly in terms of PyTorch. So you will have an added advantage. So I request those who are in academic and research domain, please go with the PyTorch. Okay, even TensorFlow is fine, but I request you to go with the PyTorch, even it is helpful for you. Okay, I have already discussed this overfitting problems. Okay, to deal the overfitting problem, I have already told you we use the validation dataset while the training is going on, where we will tune all the hyperparameters according to this validation dataset. Okay, it is the key, or we can say this is the center. Hyperparameter tuning is done with the validation data. Like here, I have already explained this graph. Suppose the white color indicates the training error or loss, whereas the green color indicates this validation loss. We have to train our model and save our particular model exactly at this point. Okay, this is our region of interest, or we can say where we have training error and testing error. The difference or the gap between training error and validation error should be minimum. The difference between or the gap between them is minimum. This is what we need. We can even say this point is nothing but low bias and low variance. This is our interest, point of interest. Okay, this is nothing but the entire theoretical part I just have discussed. In general, to deal these overfitting problems, as I told you, validation dataset we will use to tune the hyperparameters. But which kind of hyperparameters we will discuss. Okay, usually to deal this overfitting problem, we are going to have 2 other linear regressions like lasso regression and ridge regression, where both the terms will involve regularization term. Okay, even this one also indicates regularization term. This is not that difficult. Just for the sake of understanding, assume that using these ridge regression, lasso regression, we can deal the linear regression problems without getting affected by overfitting. That is the summary point. Now coming to what this ridge regression and lasso regression, you can go through them. It's not that difficult. Theoretical part. While the implementation, I will explain how exactly to use this stuff. This particular, apart from the loss function which we have designed for simple linear regression, we will have some lambda term, or we can even say some alpha term. According to your comfort, you can use any term. We can have weight square, or in otherwise you can say just weight itself. Okay, so theoretically this much is not that much necessary while implementing the things. For the sake of understanding, I am just intimating you that you guys just have to learn what is meant by ridge regression and how to use this one, what is this lasso regression and how to use this one. In the implementation part, I am going to show you two examples. One with respect to the medical data. One is related to medical data that is available in medical domain. That means some with respect to hospital data. Okay, hospital data. Okay, and the second thing is something like housing price data set. Housing price data set. Both are given in CSV format only. Okay, comma separated values we call CSV format, or we can even go for Excel format also, or Google Sheets. Okay, Google Sheets. These are the usual things you can find. Two problems I will explain. In the medical data related problem, I just discuss only the simple linear regression or multivariate linear regression, where it doesn't involve any kind of cross validation, okay, or any sort of overfitting. I don't discuss all this stuff. I just let you know how to apply this entire training data, whatever that is been given to you. After fitting that particular model, I just give the test data to that particular model and I will generate the output. That is first example. I am not going to discuss anything related to overfitting and all that issues in this particular data set. Now coming to house pricing data set, I will discuss that stuff where it involves even overfitting problem. Okay, and it will even discuss the cross validation stuff. Okay, using cross validation, we are going to tune the hyperparameter as lambda. You can even call alpha, the term that is belonging to regularization. Okay. Now coming to the implementation part, I have just shared this entire documents or the entire folder I have given to you. Just upload this particular folder onto the Google Drive. After uploading that particular folder to the Google Drive, you will get to see these three things. Okay, where you can see that this is nothing but the hospital data set, where you can see once you click on that one, you will get to see this kind of a data where it indicates number of X-rays in a particular month. At the same time, like bed days means how many beds are occupied in a single month. Similarly, length indicates how many hours a particular patient has stayed in that particular hospital. So if the number of X-rays are being taken more, that means hospital is functioning those many number of hours. I mean, increase in this number will indicate more the number of operating hours. Similarly, as the number of beds are occupied in a particular single month is very high, that means hours also will be more. Similarly, as the stay of a particular patient is more, that means his operating hours of the hospital also should be more. So all these three variables can be treated as an independent variable, and hours here it will be called as a target variable. Okay. Now coming to implementation part, this is a Jupyter notebook that I am opening in Google Colab. If you observe clearly, here we are just noting down the hospital number of hours. Okay, just open this Google Colab notebook. After doing that one, just connect, shift enter, so that particular connect to the Google Drive, it will ask you. Suppose it is mine. Okay, we are mounted at this particular drive. Just refresh this one. There you can see the entire drive, where the folder name is NPTEL Linear Regression book. NPTEL underscore linear underscore. From here, I just have to first import all these libraries, where from the sklearn I am importing the linear regression model, matplotlib for visualization, and this pandas will be for data frame analysis. Seaborn is also like more or less like a plotting library only. Here I have loaded the data. If you observe, I am just taking the shape of this particular file, df.head. It will generate the first 5 points. The shape of this entire data frame is 17 cross 4. That means 17 rows and 4 columns. The last column 4 hours indicates the target variable. These first 3 variables indicate the independent variables or features. Next is just I am finding out the how exactly this hours is related to hours. Similarly, bad days is a correlation with this particular independent, each independent variable with the hours. I am just checking out. Here I have imported the train test split, where as I have told you, I am just here splitting the data into training and testing only. There is no part of validation here in this particular problem. After splitting, you can see the length of the train is 11 because I have used 30% for training. Sorry, 70% training and 30% for testing. You can see here. Okay, this is nothing but the test data. Okay, just I am taking all these first 3 columns of into the x variables and last column into the y variable. X underscore train, y underscore train. Just check out the shape. Because I am dealing with the x train, these are the things you have to focus. Similarly, I am just separating out the x test and y test. This is nothing but the shape 6,3. These are just correlation plots. How exactly x-rays are related to hours. Similarly, how exactly bad days. All this data is related to particular month only. Okay, you can observe that most of the time they are linearly correlated. I mean closely correlated, high correlation. Instead of generating this individual diagrams like this, yeah, there is a command where you can generate all the things like this. Okay, it takes some time, just wait. This in terms of values, correlation coefficient. Correlation coefficient basically it indicates how exactly 2 variables are related to each other. Now coming back to importing this particular linear regression model, I am just writing down here at this is the main important thing. Linear regression has been imported using this function from sklearn library dot linear models import linear regression. That linear regression object I am using right now, where you can see like this. Once this is done, once the object is taken, lm.fit, this is the function we will have x underscore train comma y underscore train, and I will obtain the R2 value for this one. Okay, x train, x test comma y test. They are almostly closely related to each other. Okay, we can say that one from these two values. Here I am just doing that prediction errors. What is the y prediction and y test. This is just basically using several things. I have just extended this task. Like I have mentioned earlier, mean square error can be calculated as a metric, even mean absolute error can be calculated as a metric, and R2 scores can also be used as a metric. Here, this is the main thing is here you have to focus. Once the object is taken, just fit the model and obtain the score. Here we are just obtaining the score for original train data and test train data. Similarly, I am focusing now on x test and y test. If you observe here, both value, training value is more, even R2 score of the test data is also more. That means more or less they are equal. Okay, so we can say that model is good only. But here in this particular problem, you have used only 17 points. When we discuss next problem, you will get to know very well. These are just, you need not bother about all the remaining things. I am just extending the task, like I am just predicting the values here. Here I have taken directly R2 score value, right? Here I am just taking the entire of, if I give you x test as an input, this is how the values are. Y train predict also I have taken here. This is on test data. This is an after fitting the model. I am just predicting the x train values also. These are nothing but y predict value, y test value. You can see here the original value is 628, out is testing test data. This is how the value is. Okay, 16939 means 1854 here. Like 10, so last one if you take 1611, here is 1489. This means at least more or less close to the original values. Okay, this is good enough. This is like mean square error, mean absolute error, and R2 score. I am just directly importing these functions instead of using this particular formula like lm.score, which I have used here. This is another way of doing this thing. This is just an extension, no need to bother. Till now we have done, what I have done is just I have taken the data and I have splitted the data into x train and y train. Similarly, x test and y test. After doing that, I have fitted the model. After fitting the model, I have found out the R2 score value. After finding out this R2 score value, and even I have experimented with the mean square error value and mean absolute error value also. But doesn't make any sense to using, not necessary to use so many things. You can take a single metric and you can comment on. Where mean absolute error and mean square error should always be small, we will expect. Whereas R2 square value will remain in 0 to 1. Okay. But we expect the value to be 1, near to 1. I have just extended that one. In most of the cases, in general, the data set having several variables. Suppose in this case we have x-rays, bed days and length. If you observe the data like this here, see all these data points, length values are very small actually compared to the remaining variables. Okay, to let the model not to get confused too much, we will bring all the columns to following a particular distribution like normal distribution. Okay, so we will bring all the columns of the features to follow a particular normal distribution. Normal distribution is nothing but standard deviation is having plus or minus 1, where this particular mean value should be 0. To do that one, we have directly some libraries. From the library we can import that one even. Here, see here, standardized data like x minus x mean whole divided by sigma. This is the formula we will use generally for standardization of data. Like suppose xi have xi minus xi bar whole divided by sigma. Okay, in other words we can say xi is equal to xi minus xi bar or mu whole divided by sigma. This is how we will give. Okay, to do this one, we have something like a standard scalar function is there. Similarly, min-max scalar is there. Standard scalar will have -1 to +1, we will bring the data to this value. Whereas here min max scalar, we will convert each and every column variable to values between 0 to 1. This is how we will do. For that one, here I have just done the manual implementation, like x minus x bar whole divided by sigma. See here, all the values will range between -1 to +1 only, even this one. Okay. No, sorry, sigma value is +1, standard deviation, like standard normal distribution in the sense like this one. Sorry, I'm sorry. Suppose if this is how the data, this is 0, you will have up to plus sigma, minus sigma, plus 2 sigma, minus 2 sigma, like this data will distribute. Okay, I'm sorry, I just told -1 to +1. That is not the case. Okay, we can say that mean is 0 and sigma deviation is 1. That is the case. Okay, that's good. Just manual implementation they have done. Now coming back to, let us check. Standardization has been done. What we are doing here is, without standardization we have done, similarly with standardization we are doing here. Since here the data points which we are using is very less data points, like 17 rows and only 4 columns, but if the data set is more, the data points is more, you can see that particular difference. Okay, always this normalization will always help to converge the model fast, and at the same time very well. Just we have done the earlier things only, just I am doing R2 square is not defined because I didn't run this particular program, I think. From R2, where it is. See here, I didn't run this one, that is why problem occurred. Okay. Standardization has been done. For the training test data, training data. Always remember, while doing this normalization, whatever, suppose I am doing the normalization for X data, like train data, we will compute mean and standard deviation for each and every variable, and I will X minus mu by sigma. I will do like this. Now comes to test data, xi minus mu minus sigma. Use the mu and sigma of what we got. Now when it comes to standardization, suppose I am doing the standardization for X train data, we will use like xi minus mu sigma. This mu and sigma are computed from the training data only. Assume that I am talking about the standardization for a particular variable like xi. Okay, this xi is a variable where number of data points I have is I is equal to 1 to m. And among these number of data points, like 1 to m data points, I am just focusing on particular variable or particular feature only. Now I have to standardize this data. Like this formula I will use like xi minus mu divided by mu. Mu is nothing but xi bar, where sigma is nothing but the standard deviation, how we compute normally. Okay. This is how we will do the standardization for the particular variable in the training, while standardizing the training data. Now it comes to test data standardization, where we will have only the same variable I am talking about, like xi minus, use the same mean and standard deviation that I have used are calculated for the training data. That is the basic difference. Okay, please keep this point in mind whenever we are doing standardization. While doing the standardization, when we are dealing with the training data, to compute the standardization, we will use this formula like xi minus xy bar whole divided by sigma. Similarly, for the test standardization, we will use the same mu and sigma. That means we are not going to compute the new mean and sigma for this test data. Please keep that point in mind. Even here, there are some functions like standard scalar or min-max scalar. These functions are available directly. Even while doing these things, you just have to be careful how to use them. Okay. After doing normalization, again I have run the code. This is how the values are. If you observe clearly, there is no much difference, because in general the difference you can see, but here I have used the basic very less number of data points and very less number of features. That is where this problem is happening. So in total, just I have just predicted the y actual data and predicted data, like y test and y predicted. I have just computed here something like this: y test and y test train scatter plot. For these the plots I have done. Scatter plot you can observe, that's not that difficult. Here I have used another min-max standardization. I have just, after doing this entire thing, you can even see the those coefficient values also you can see like this, using this function like lm.intercept, something like this. Okay, just go with this code, you will easily understand what exactly is going on. In total, as a summary, I can say that you just have to be familiar with NumPy library, Pandas library, Matplotlib library, scikit-learn library for machine learning, and the deep learning for PyTorch and TensorFlow. That's it. This is the new example which I told you earlier, that which it involves both overfitting problem, and even here we will use this cross validation for the hyperparameter tuning. Okay. In this, for the hyperparameter tuning, mostly here using, apart from just regular linear regression function, we are going to use two more functions like ridge regression and lasso regression. Theoretical part is according to your convenience, you can browse for it. It's not that necessary. But let me show you the implementation part. Okay, I have already given you this particular entire data set or this particular folder. I have given you. Just upload this particular folder to your drive and just open this linear ridge lasso regression IPython notebook. Okay, once you double click over this one, you will get here. Okay, if you observe here, our first job is to just mount your drive. Okay, let me check. Once this drive is being mounted, the data set which we are using here is, just let me, the data set which we are using here is from Kaggle dataset, where you can call this one as Melbourne Housing Market. And for doing this tutorial, I have taken help from Code Basic channels, that is in YouTube. CODESACS YouTube channel is there. I am referring his videos actually, or his lectures for implementation part. If you have time and if you want to explore more algorithms, you can go and check there. I have taken reference from there. Now let me explain. This is the data set. Just click here, this particular data. This is for namesake, I am just explaining, but in the folder I have kept already downloaded data from both the points from Kaggle. Click here data. If you go down, you can see both these files. Just click this download button, entire download button here. You can download all the files data. Okay, this is how the data has been given, like suburb and address, rooms, type, price, method, seller G. If you want, you can further explore here. Each and every detail has been given, what exactly each data point, each column will describe. Okay, method, type, seller G, data sold, all the each and every variable's particular description has been given. Okay, after mounting the trail, I am just importing NumPy, Pandas, Matplotlib and Seaborn libraries here. Okay, just refresh here. after mounting your tray. See, I am taking the path from Melbourne linear regression data. Melbourne, see here. From this folder I am taking my data set, and the CSV file which I am taking is from that particular full.csv. Just go to that particular file, wherever that particular file is there. Google Sheets, this one, not this one. See here, just go to this particular file and click here. You can see the copy path. After obtaining this particular copy path, just paste here. Okay, that is how you will give the data. Just let me do path. Okay, so my data set has been taken into a pandas data frame like pd.read_csv. Now coming back to exploratory data analysis, I am just checking out the shape. Like that means I have 34,857 rows and 21 features I have. Not features, even along with the last variable like price we are talking about here. This one, this particular column is our target variable. Remaining all the columns are features. That means among those 21 variables, we just have to focus on only 20 variables. All the independent variables are features, and only one is target variable. Just I am printing down what are the head files, like first 4 rows I am checking out. This is the basic function people use. And now just check it. And this dataset.NUnique is for checking out what each individual, suppose if you take the rooms you can see 12. That means 12 unique numbers are there. Okay, like 3s are some 3 is one number, unique number, 2 is one unique number. Likewise, we will have some 12 unique room numbers. Okay, rooms. So okay, this 21 column, instead of taking all these 21 columns, I just have focused on these columns. So let me check out from the data frame. I am just filtering out only these number of columns, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Total 15 columns I am using. Just let me check the shape here. See here, I have only 34,857 rows and 15 columns. Earlier the column number is 21. Now the column number is 15. Now check this function. What it indicates is, maybe in the given data set, you will be having some blanks, not filling any data. We people usually call them as NaN values. Okay, you have to deal in the data pre-processing stage or exploratory data analysis stage. You have to focus more on those details. This particular blank value can be replaced with the zeros or even with the mean value of the remaining values, whichever present to that particular variable. Or in another sense, you can just eliminate that particular row. Even that is also accepted, because while feeding the deep machine learning models, those models cannot accept the data that is having these NaN values. Okay, so please keep this point in your mind. So dataset.isNA.sum. Now come to see here, for paper count, property count, distance. Property count, we have 3 NaN values, distance 1, and bedroom, bathroom. For all these 4 columns, I am just focusing to fill those columns with the zeros. I mean, wherever those blank values are, NaN values are there, I just replace all those values with the zeros. See here, suppose if you go observe property count, you can see here 3 blanks are there. Now here see 0 it became. Okay, similarly take the distance has only 1, that even that 1 also becomes 0. Now bathroom, car deck, see the car 8728, car values now become 0. That means there is no blank values. What exactly blank values I will show you. See here, suppose if you observe the price, there is no value here, there is no value here, there is no value here. All these blanks, see here, bedroom 2 in this particular sheet, no value, no value, no value, no value, no value, no value. No value doesn't mean a 0 value. Okay, now coming back to land size and building area. Okay, see here, only these 2 are left. Now land size and building area, for those columns I am just replacing with the mean values of the remaining values. Okay, take the land size, wherever those blanks are there, I am just filling those values with the mean of the remaining values. that are given in that particular land size variable. Just let me run this one. Now let me run this one. Some value. See here. Only region name and council areas are left. Still I have to work out something for them. I am using just dropping out those columns. So those complete rows which are having, see here. Now this function indicates in the entire data set, whatever you have, like suppose you have a entire Excel sheet. You see, for the now whatever data I have prepared now, for all the entire data, wherever you see, you cannot find these kind of blanks anywhere in this particular data set, which I am going to feed to the model. So keep that point in mind. Here I have used all the strategies, like to fill the NaN value or a blank value or a blank in the data frame. I just, for a few columns I have filled with 0 values. For a few columns I have filled with the mean value. For few rows, for few columns wherever the NaN are present, I just have removed that entire row. You can go for this one. Suppose those number of blanks are very less, then only you can go for this one, because with very high efforts we are collecting the data. So the entire deep learning, machine learning algorithms, they are very much interested. They are very much trained well if you have very good data. So you don't try to lose even a single data point. Okay. So always try to use every data point whichever you have. Okay. But for the explanation sake, this is how we can do several pre-processing tasks. I hope everybody got it. Now coming back to observe the shape here. 27244. Okay, rows. Earlier the row numbers are like 3, 4, 8, 5, 7. Because at the end we have pricing column where it has 7610 blanks. I have removed all those rows whichever doesn't contain price. Okay. Now coming back to, usually if you observe in the columns like the suburb, you can see usually deep learning models or machine learning models, they can understand only in numbers only. But here you can see there are strings, okay, or categorical variable. I have to convert all these categorical variables into one hot encoded variables. Okay. To do that one hot encoding, just go and browse what exactly one hot encoding means. Okay. To do that one hot encoding, you will have a function something like dummies in pandas that will help you to remove that categorical variable into converting variables into one hot encoded variables. Just run this command so that everything will be easy. See here, I have already told you price is nothing but my point of interest. I mean that this target variable, I am just separating out x variables and x data and y data. I mean features and target, or input variables or output variable. Now coming to x data shape, see here 744. Observe carefully. Earlier the shape is 27. Earlier the shape is actually 27244, 15. Observe here, after running this one I have run, that is why this problem occurred. Earlier we have 27244, 15. After using the dummy function, we got 745. Okay, so keep that in mind. I mean, those 15 features has been now converted into one hot encoded 745. Okay, that is what this value dataset.shape. This one. 744, because we have separated out the price variable, that is the y contains 2744. As usually, now we have separated out the input variables and output variables. Now coming back to scalar.model underscore selection import train test plate, train underscore x comma test underscore x. You can usually know just x variable and y variable given, and see here 0.3 is the, that means we are just converting the entire train data into 70% of train data into train data and 30% into test data. Observe the shapes. This is how x train, x test, y train, y test. Now we just first implement the simple linear regression model. To import that, just import this linear regression fit of train underscore x comma train underscore y. Okay. After this one, obtain the regression score or another R2 score. This is the test data. Coming back to see here, this is in this particular problem. You can observe that after training this particular model, when I am checking out my test data values on this one, the score for the test data I got is 0.138 or 13%. Whereas for the train data, I have training error, that particular score is 68% or 0.68. That means you can see a huge difference between 68% and 13%. Okay, that means training here R score indicates more or like accuracy. That means in terms of loss, you can say that training error is less, but the test error is more. That is where we call as overfitting problem. So to deal this particular problem, we go for lasso regression or ridge regression. If you observe the lasso regression, see here, lasso alpha is equal to 50, maximum iteration is like 100, TOL is nothing but the tolerance level 0.1. This is just functions only. You just have to learn how to pass this train x and train y into this one. Alpha is equal to 50 indicates here that regularization parameter. Suppose let me train this model using lasso regression. See here also I am not using any cross validation here. I am just using this alpha values, like regularization parameter only I have used. I didn't use any validation data here. Now coming back to regression score. See here on test data we have 0.6636, whereas on train data we have 0.68. You can see very minute difference is there. That means that particular overfitting problem has been dealt by the lasso regression. This is the basic difference one should know. Okay. To improve this model further, I have used with the cross validation, but it is taking more time to run the program. Once I explain this ridge regression and ridge cross validation, later you can observe this course. At the end, please try this one. Okay, so that there is no complication. Now coming back to ridge regression. Here also this function, import this ridge regression function. Alpha is equal to 50, maximum underscore iterations is equal to 100, tolerance level is equal to 0.1. That's it. Let me run this one. Next, lasso underscore regression dot fit of train underscore x comma train underscore y. Let me check the regression score here. Here this particular score, here that particular score indicates the R2 score only. Okay, or R square value. See here 0.66, 0.68. Very minute difference is there, not much. Earlier if you observe the simple linear regression, 13% and 68%. See how much difference is there. So that is how you can dealt. Till now we didn't use, to tune these hyperparameters, we didn't use any validation data till now here. Now if you observe this ridge regression with cross validation data, till now I have dealt whatever I told you, simple linear regression and ridge regression and lasso regression, all are with only without validation data. Okay. Now ridge regression, we are dealing with the validation data. The score or the metric I am observing here is negative mean squared error. Okay. Observe, this is not a R2 score value. Please keep that point in mind. Now let me run this one. Ridge regression. Just learn how to use which algorithms well. Okay, that is more than enough. See, it is taking some time. See, here I am trying different alpha values 1, 2, 3, 4, 5, 6, 7, 8 like this from 10 to the power of minus 15 to 100. Okay, still it is going. Our ultimate thing is to train error and test error, or train whatever metric you are going to use. Those metrics should be almost close to each other for the training and testing. Then only we can say that they are going to do as a okay. Here I am observing the negative mean squared error. Please keep that in mind, not R square value. Now I am printing down the best parameters and metrics. See here, for the CV is equal to 5 I have used. That means I am dividing the entire thing into some cross validation of 5. Okay, that is the parameter. That means instead of using the entire train data, whatever I have given as a 70% data, among that data, few points will be act as a validation data also here. Okay, please keep that in mind. That is where the cross validation part will come. Now use the regression score on this one and regression score on this one. These are negative mean squared error only, not that one. See, observe both the values. You can see that both are almost close to each other, like 12 and 30. Okay, maybe the value is large. That is how we will tackle the regression problems. Whenever there is any overfitting problem, we encounter with the either ridge regression or lasso regression. You just observe by removing these comments. Whatever I have sent into that particular folder data, just print this one, these two things also. Okay. Grid set CV indicates the cross validation part only. Please go through this one. This is the end of the tutorial. Thank you so much.